Morning.
Morning.
You guys? Homework, lads. I got, well, 2 turned in yesterday, 4 this morning, so I haven't had a chance to correct those. You need to be doing your work, otherwise you're just going to be lost. Test is next week. If you haven't been practicing, it's going to be a disaster. So what I'm noticing, there's a lot of small, silly mistakes that people are doing. You have to pay attention to the detail. Can you remind me of the page number again? 264?
286.
286. Thanks. Okay. So I'm going to go through a few of them. Sorry. Here we go. Right. So I'll take some of the combination ones, like question 4. So you have y is equal to 1 over x squared plus 3x squared. How do I get that into the form? The only formula we have learned so far for differentiating is d dx of x to the power of n. So if you're differentiating x to the power of n, you bring down the power and you reduce the power by 1. That's all you have to do. Okay? Same rule over and over again. But to do that, it has to be in the form x to the power of n, which this is not. So how do I change it? John, how do I change it? What does 1 over x squared become? Sorry?
Is it x minus 2?
Good. Okay. And the rules for all of those are in the tables. This is in the right form, so that can stay as it is. So before you differentiate, you have to get your function into this form. Now, when it's in this form, you follow this rule. So dy dx, bring down the power, which is negative 2, and the power goes down by 1. Minus 2 minus 1 is minus 3. Bring down the power, which is 2, multiplied by 3, you get 6. New power is 2 minus 1, which is 1. You don't need to write a power of 1. Then we're going to differentiate it again. So there's no point in putting this back into that form because you have to differentiate it again. So it's in the form, they're both in the form of x to the power of n. So we bring down the power, minus 2 by minus 3 is 6. Take away 1, minus 3 minus 1 is minus 4. Bring down the 1, you've got 6 ones is 6. Take away 1, the power is 0. So that's just anything's power of 0 is 1. And now at the end, you can put it back into the correct form. X to the negative 4 goes under the line to become x to the 4 and 6. Oh, sorry, everyone. Question 8, where you've 3x, I'm sorry, you didn't have that one. Question 7, 2x plus 3, y square root of 2x plus 3. Again, to write it as a power, square root means there's a little 2 in there that we never bother writing. So it's 2x plus 3. There's no power under. This is the root, so it becomes the denominator of your fractional power. Now, that's in the format of something to a power. So we bring down the half and we reduce the power by 1. But we also have, this is not plain x here, so we also have to multiply by the derivative of what's in here. That's the chain rule. So dy dx The derivative of what's in this is 2. Do that first so you don't forget. Then you go ahead and for the power of a half, you bring down the power, so that's times a half. Keep what's in the brackets and reduce the power by 1. So a half minus 1 is minus a half. 2 times a half is 1, so they cancel. Doing it again, bring down your power, you've got minus a half times the derivative of this is times 2. So 2 times minus a half. What's in the bracket stays the same. This goes down by 1, so that's minus 3 over 2. The 2's cancel, you're left with the negative. Bring this below the line, it's 2x plus 3. The power of 3 over 2 means square root. Okay, so that's the basics. You have to put it in the form of x to a power. And once you've done that, you bring that power down and you reduce the power by 1. If this is not safe to use the chain rules, you have to get the derivative of what's in the brackets and multiply it. And then at the end, put it back into similar form to what you started with. So any questions on those so far? Okay, because this is not plain x, so it's basically y is u to the power of a half and u is equal to 2x plus 3. So I have to do dy du, which is a half u to the minus a half, and then du dx is 2. So that's 2, that's the half, the u is 2x plus 3, the minus a half. So the chain rule, instead of having to go through all this every time, you should be able to recognize that you get the derivative of what's in the brackets, that's your du dx, which is the 2. And then, so it's 2 functions. So the first function is 2x plus 3, derivative of that is 2. Second function is the power of a half, so the derivative of that is a half by whatever it is, the power of minus a half. And then the same thing's going on here. You get the derivative of this, which is 2, bring down the minus a half, and then you take away 1. Does that make sense? Okay. Question 10 was pretty straightforward. Xy is equal to x to the power of 4 minus x cubed plus 4x minus 1. Find d2y dx squared, so you get the derivative. Down the power, take away, bring down the power, take away 1, bring down the power, take away 1. Do it all over again. Bring down the power is 3 fourths is 12, take away 1 is 2, 3 twos is 6, take away 1. Constant disappears. Then it said find the values of x for which d2y dx squared equals to 0. In other words, what values of x make this equal to 0? So you're solving 12x squared minus 6x equals to 0. You're solving a quadratic, you factorize it. First thing we can take out is 6, we can also take out x, and you're left with 2x minus 1 is equal to 0. 6 can never equal 0. X could be equal to 0, and 2x minus 1 could be equal to 0, so x could be equal to a half. So that's the 2 values of x that would make this equal to 0. So you have to kind of understand what the question is saying. Find d2y dx squared, do that. Find the values of x which make that equal to 0. So set it equal to 0 and solve. When you're finding values of x, you're solving. Is that okay?
Yep.
Question 11, you have 3x plus 4 over x, that's y. Or, yeah. This is not in the right form, so we change it. Okay, and then we get dy dx using our normal rule. So bring down the power, take away 1. Bring down the power, that's minus 4x minus 1 is minus 2. It's not 0. Subtract 1. Then you do it again, d2y dx squared. The constant disappears because you've x to the power of 0, so 0 times 3 is 0. Then you bring down this, so you've got minus 4 by minus 2 is plus 8x, and this minus 2 minus 1 is minus 3. And then it wants to show that x squared times d2y dx squared, which is that, plus x times dy dx, which is this, and minus y, which is this, So show that that equals 0. So let's see what it is. So when you're doing this, you're doing your SNL. So numbers here are 8. X to the power of 2 times x to the minus 3. We're multiplying the same base, so we add the powers. So 2 plus minus 1. Is that okay? Plus x by 3 is 3x. Then you've got minus, plus by minus. Number is 4. X by x to the minus 2 is x to the minus 1. Because if 1 minus 2 is minus 1. Minus 3x minus 4x to the minus 1. And if you look at the x to the minus 1s, you've got 8 minus 4 minus 4, which is 0. And you look at the 3 x's, you've got 3x minus 3x. So that all equals 0. Because they all cancel, and those two cancel. If you don't practice doing these yourselves, guys, it's not going to magically happen for you in the exam. I'll just go straight to... You want me to go through 12 or 14 or either or both? Okay, so 12, you've got f of x is equal to 2 over x, which is 2x to the minus 1, plus 4 root x, which is 4x to the half. So differentiate. Now, when they say f double prime of 4, that means you have to get f double prime of x and then sub in 4. So when we differentiate this, we've got minus 2x take away 1. So every time I'm just bringing down the power and taking away 1. Bring down the power of 4 halves is 2, take away 1. And then you do it all over again. Bring down the power, minus 2 by minus 2 is 4. Take away 1 from minus 2. 2 by a half is minus 1. And then that's x to the negative 3 over 2. So that's your f double prime of x. They want you to work out f double prime of 4. So wherever there's an x, we're going to put in 4. We've got 4 times 4 to the negative 3 minus 4 to the negative 3 over 2. Okay. Now you can put that into the calculator like that. You can just do 4 brackets 4 to the power of negative 3. Oh, sorry. Minus 4 to the power of negative 3 over 2. And that's minus 1 over 16. Which is what we want to show. Or you can say that's 4 by 4 to the minus 3. So you're doing 1 minus 3 is 4 to the negative 2. Minus 4 to the minus 3 over 2. So that's 1 over 4 squared. Minus 1 over 4 to the 3 over 2. 4 squared is 16. 4 to the 3 over 2 is 4 to the half is 2. Because the square root of 4 is 2. And 2 cubed is 8. So you've got 1/16 minus 1/8. Which is minus 1/16. So that's just subbing in then. Okay. So if you're asked to find f prime of a number or f double prime of a number, you differentiate first, then you sub in the number. Does that make sense now, Andrew? Or okay. And then what about 14? You want to go through that, or is that okay? Just kind of more the same. So you just go through, change it into the right form, apply the rule over and over again. Now, the next section, we're on to new rules. We're moving on to different types of functions. So in the next few sections, we're going to go through trigonometric functions. We're going to go through powers. We're going to go through logs. And so we're moving away from our x to the power of n. And so when you look at the calculus page, the derivatives page in the tables, there's our basic rule here. We also have all of these other ones, which is what the next few chapters about. So you've got have we come across ln before, the natural log of x?
Don't think so.
No, okay, so logs, basically logs, we'll go through them later, but they're the opposite of exponents. Okay, so these two are inverses of each other. So we're going to go through those two functions, and that's variations on those. Then we're going to go through, well, we're going to do these ones first, sine and cos. and then the inverses of those. So sine, cos, tan, and the inverses of those. Okay, and there's a kind of a section on each of them. So I may not do them all yet because I'd like to maybe do a little bit of revision before the test, but I certainly want to do the sine and cos and maybe the e to the power of x. So 7 is sine and cos. And the differentiating part is easy in that you just have to remember that sine changes to cos and cos changes to negative sine and tan changes to sec squared. So they're all there in the yellow box at the top of the page. You see that? Okay. And they're also on that page in the tables. So you don't have to remember that, but you'll be doing it often enough that you kind of need to remember. Now, where it gets complicated is that you're not going to just have plain sine x, cos x, tan x. So we're going to have to use our product quotient and chain rule as well as the sine, the cos, and the tan. Okay. So I'll give you some examples. I'm going to write down there. Okay. So example 1 here. The numbers in front don't matter. They're just constants, okay? So you just have to do dy dx. The sine x changes to cos x, so that becomes 3 cos x. And the cos x changes to minus sine x, so that becomes minus 3 sine x. Is that okay? So that's a rule. You don't need to worry about where it comes from, okay? Now this one, we've got x squared multiplied by sine x. So that's product rule. So our u is the first function, v is the second function. Okay, so remember our product rule, you have to differentiate each function on its own. So we do it over at the side. So u prime is 2x and v prime is cos x. Is that okay? Anybody, any questions on that? Okay, so now dy dx is going to be, remember it's uv prime, so we kind of crisscross plus vu prime. So that's going to be x squared cos x plus 2x sine x. And now when we are doing these, we're kind of moving along from SNL, because we've our Saturday Night Live, signs, numbers, letters, and you also have functions, which might be cos, sine, tan, e to the x, ln x, whatever. So it's SNLF, okay? So when you're writing them down, sign, the number, the letter, and then if there's a function. Now, where these get really complicated is with the chain rule, because you can have products, you can have sine, you can have the x changing, and you can have the sine changing. It might be sine squared or sine cubed, okay? So let's have a look at those. Okay, and really try and focus on this because it is a little bit tricky. So let's take a simple one first. I'm going to do sine. That's. I'm going to do. Okay, I'm just taking down the examples out of the book to go through them step by step. So first one, if y is equal to sine 4x. So now we don't have a plain x here. So we have two functions. It's a composite function. We're doing a chain rule. So our input is x. The first function is times 4. The second function is sine. So I could do that step by step. I could say let u is equal to 4x and v is equal to sine, or y is equal to sine u. And then I have u prime is equal to 4 and y prime is cos u. And then I'm just multiplying these two by each other. That's 4 cos, and then u is 4x. Okay, so what you don't want to have to go through this every time. So what you have to do is recognize my first function is 4. So the derivative of 4x, sorry, so the derivative of that is 4. My second function is sine, the derivative of that is cos, and the input to that won't change, the 4x. The input to this would be the input to the cos. Is that okay?
Yeah.
Now here's another one. My first function is x squared, so if I get the derivative of that first, it's 2x. The second function is sine, the derivative of that is cos, and the input to that still stays the same. Okay? So it's chain rule. This one here, the first function is 3x squared plus x. So when I do that, that's 6x plus 1. The cos changes to minus, so I'm going to put the minus in front because we're doing SNLF. And cos changes to sine, and its input stays the same. So before we move on to these powers, does everybody see what's going on there? Would anybody like me to go through another example? Or is that making sense?
Makes sense.
Okay, two functions, so you get the derivative of the first function multiplied by the derivative of the second. But don't forget that the input or the argument sine, cos, tan is going to stay the same. Okay? So what's in the bracket here, right after that stays the same. Now with this one, when you see a power of a trigonometric function, the reason that's really equal to sine x to the power of 4, but just to avoid writing the brackets, we put the 4 here. So that's not the same as sine of x to the power of 4. Okay, so be very careful where the power is. So the 4 is applied to the sine, not to the x. Can you see that?
Yeah.
Okay, so it's just the way we write it to avoid putting brackets around. We put the 4 saying it's okay, I would get sine x first, and then down to the power of 4. Okay, so it's just a particular way of writing powers of trigonometric functions. So now my first function here would be sine x, and the derivative of sine x is cos x. My second function is to the power of 4. So when I derive that, I bring down the power. I still have whatever this is, which is sine. Then my new power is 3, because 4 minus 1 is 3, and I still have the same input. And then with these, you probably have to do a bit of rearranging to get signs, numbers, letters, functions. And when you write more than one function, do them in increasing powers. So that's why the cos x comes before the sine cubed. Okay? So you don't leave it like that, because you want to distinguish the inputs, cos x times sine cubed x. So I'm going to go through another example of that. So say y is equal to cos to the power of 3 times 2x squared plus 4. Now this is as complicated as it gets, because we have 3 things going on here. We've got the input, so we have to get to the derivative of that. Then we've got the trigonometric part, so we get the derivative of that. And then we've got the power, to get the derivative of that. So you have 3 different things there. So we're doing the chain rule. We're going to have 3 derivatives. So you get the derivative of the bit in bracket first. That's going to be 4x. Okay. Then get the derivative of cos, which is negative sine. And its input stays the same. So every sine and cos must have an input, and that input never changes. I'm just going to put square brackets around it. And then I have to do the derivative of the power. So I bring the 3 down, cos stays the same, this goes down by 1, and the input or the argument stays the same. So you have 3 different functions there, 3 different derivatives, which all get multiplied. And this is where your SNLF really comes in. So you look along, you see I've got a minus. Numbers, I've got 4 by 3 is 12. Letters, I've got x. And functions, I've got sine, 2x squared plus 4 times cos squared, same function. Okay, so this is probably the hardest you're going to have, okay? But if you just these separate functions. Do you want to try one some yourselves, or do you want me to go through another example?
Go through another example.
Okay, and I'm just making them up, okay? Say y is equal to tan to the power of 5 times 3x to the 4 minus 2x squared plus 6, okay? I'm making these pretty complicated. This is our first function. That's number 1. tan is number 2, and this power is the third function. Okay? So the first function, I get the derivative of that, which is, that's a plane using our normal rule. Bring down the 4, you have 4 3s is 12x cubed minus 4x squared, and the constant disappears. So I've done my number 1. Tan, if you look for the derivative of tan, that's x squared. So sec squared, and the input will stay the same. So those brackets stay the same. That's the second function. The third function is the 5 to the power of. So I bring down the 5. It's applied to this tan. So it's 5 times tan. And then the power is applied to the tan, goes down by 1, and the input stays the same. And then you kind of simplify it all. You look along, no signs there. The first number is 5, nothing to multiply back. The next thing is the algebra, that's one function. And then I've got the sec squared, that's another function with its input. So all of those have an input. And then I have the tan to the 4. So let's get you guys practicing on some. So you'll see it here in the book, using the chain rule twice. We're actually using it 3 times. So those in the book are the exact same type of thing, only you can simplify what we just did. And then example 3 is the quotient. We're going to go through example 2 or 2. Probably should just start. I'm going to run through example 3, okay? Because that's a little bit. Let's just leave that for tomorrow. Let's just focus on doing operations. So, question 1, you can do parts. Question 1, parts 4. Well, let's say 2, 4, 7, 8. Question 2. 5. Question 3. Okay, we'll leave it at that. Okay, so it's basically 1, 2, 3, and 4 for certain parts that I write. Yeah. Many more chapters, Aaron. I don't think we're going to get through all of chapter 7 because I think we probably need to leave a little bit of time for revising. Your test is on Tuesday. And I have put up the chapters on Classroom. So the test is on Tuesday. You'll have coordinate geometry of the line, probability, maybe a little bit of statistics, geometry, which is our theorems and applying those, and then this chapter here. I think if we could get these ones, if I can see good work on these, I may just stop at that point and we can do the rest. I'm conscious that it gives us a lot of work to do next year as well. Okay, and this test is 30% of your final mark. Okay, 50% is from previous assessments during the year and 20% on work submitted since we started going online. Okay. What's today's Tuesday? We may do e to the power of x and maybe leave it at that. Yeah, I think what I'll do is I'll just skip from after, we'll skip to 7.9, and we'll leave it at that. And then if you guys think about if there's anything in particular you want to do revision wise, and let me know, send me a message. So if you're getting stuck on any of these, or if you want to check them, just say, and I can run through them very quickly. You doing okay, lads? Does anybody want me to go through anything?
Yes.
Okay, I'll let you go, lads. I put up the video solutions anyway, and send me a message if you're stuck on anything, okay?
Thank you.
All right, see you tomorrow.
Thanks.